Hello everyone, and welcome back to our Introductory Programming in C series. In this video, we're going to be going over operators and expressions, so let's get right into it. So C has all your standard arithmetic operators such as addition, subtraction, multiplication, and division. So arithmetic operators, we have addition, subtraction, or negation, which we'll get into. Division, that can also be interesting. Multiplication, and modulo. So let's give an example for these. Let's go over to this program over here. We have three integers, a, b, and c. A is set to 1, b is set to 2, and c isn't assigned anything. So let's just do c equals a plus b, and clearly that should give us 3, but let's just compile and run that. And we get 3. All right, nice. We can also do subtraction. So if we do the dash, we should get 1 minus 2, which is -1. Let's see. We get -1. Something important to note is that you can also use the dash as negation. So if I take away this a variable, this is essentially a unary operator, which means it's just acting on a single variable. And what this will do is negate b. So b is +2 here. And what this will do is make it -2. So if we have a look, compile and run, you can see we get -2 down here. All right. Another interesting example is division. So here, if I go a divided by b, because a and b are both integers, what will occur is integer division, which is where, because integers don't have any decimal places, what it will try to do is see how many times does the denominator wholly go into the numerator. So in this case, 2 doesn't fit into 1 at all, right? It's 0 remainder 1. So you'll get 0 as the result. So let me show you here. Clear that. Compile and run, you see we get 0. Now, if you want to get the correct answer of 0.5, what you need to do is make sure that you're using floats. So if I do, let's see, if I make a float called d, and then I will say d equals, now these need to be a float, or at least one of them does. Let's run that. Oh wait, I didn't. I didn't change the variable we're printing up. There we go. Okay, that should work. Nice, and you see we get 0.5. So if both of these are integers, the result will be integer division, which is, how many times does the denominator go into the numerator without any remainders. However, if one of them is a float, then the standard division that you're used to will occur, and we get the correct answer of 0.5. However, that will need to be stored in a float variable or a double, because obviously if you're storing it into an integer, it can't store, decimal values. All right, let's move on to multiplication, which is pretty straightforward. We can do, let's just delete this. We can do C equals A times B, and that will just give you print. Okay, that's all good. That will give you 2. So let's have a look. Compile and run, and that gives us 2. All right, the last one to go over is modulo. So this might be one you're probably not familiar with. So if we go A and then the % B, what this means is it'll give you the remainder after division. So in our example here, 2 doesn't go into 1 at all, but we get a remainder of 1. So what this will do is give us the remainder value. So if I compile and run it, you can see here that we get 1, because 2 goes into 1 0 times with 1 remainder. Okay? All right, I think I covered them all. Let's go back here. So we've gone over these arithmetic operators. There's also the topic of precedence. So if you have multiplication, division, and modulo, these have higher precedence than addition and subtraction. So if we go back to our example over here, if I do, let's say we go a plus b times a. When this compiles and runs, what will actually happen is this here will get calculated first, and then this part, because the multiplication has a higher precedence than the addition. Now you are able to actually enforce your own precedence by putting in brackets, or the brackets like these ones. So what we can do, if we want a plus b, if we want this part to actually have high precedence and be calculated first, what we can do is do the brackets, and then this way, this part will be calculated first, and then the result will be multiplied by a. So let's go back here. Oh, let's just run it and see what the result is, because why not? Okay. And we get 3, because we're getting a plus b, which is 3 times 1. Cool. Okay, let's go back here. Let's get rid of the terminal. So, yep, we've gone over that. Precedence can be enforced using brackets. Oh, I think the correct terminology is parentheses. I think that's how you spell it. Okay. Something else to go over is casting. So if we go back here, you can actually make a variable into a different type on the fly. So for example, if I wanted to do, let's say, what's a good example? If we go back to our example we kind of used before, where we have a float called d, and then I say d is equal to a divided by b. And then let's just do this. And then let's print out the value of that. Now, take a second and think what this is going to equal. D equals a divided by b. Okay, I've given you a second. So what's going to happen here is, remember, we're doing integer division because a is an integer and b is also an integer. Even though we're storing the result into a float, which can handle decimal values, this division here will be integer division. So if we run this program, let's have a look, let's compile it, let's run it, we get 3 because d is a, have I confused myself? Let's see, a divided by b, I have confused myself, is 3. Why is it 3? B 2 a half, but that should be integer division, right? Which means we should get 0. Did I save it? Oh, I don't think I saved it. Okay, cool. I thought I was crazy for a second. Okay, we get 0, which is the correct answer, because we're doing integer division, because both of these variables are integers. However, if we wanted to carry out the standard division to get the correct answer of a half, one of these variables needs to be a float or a double. So we can do that on the fly by using the cast operator. So I can do float. Now again, this is an example of a unary operator where it's acting on a single variable. So here we're saying that make a, treat that as if that was of type float. So you can do that on the fly and then think of what this division is going to equal now. All right, I'll give you a second. Let's compile it and let's run it. And we get 0.5, which is the correct answer. And we get that now because a is considered a float, so we're no longer doing integer division. Okay, awesome. That was interesting. You can cast variables to different types on the fly. Cool. What else do we have to go over? Dividing by 0. Cool. So what can happen? You can get interesting results when you divide by 0. So let's just say we do, let's just stick with c for now, which is an integer. And let's go a divided by b, but this time let's set b equal to 0. So this should result in an error because you can't have 0 in the denominator. Denominator. Okay, so let's compile that. Let's run it. And oh, I'm printing out the wrong variable. My bad. C. And that is of type int. Cool. Let's do that again. And everything should crash. No, nothing's crashing. Why is that? Really? Let's see, have I made a stupid mistake again? B is 0. I'm saying A on B. C, and then print that out. Weird. I thought we would have got an error. No errors, even though B is 0. What happens if I make A 0? What happens if I put 0 here? Let's see what happens. Okay, you get 0. But the program doesn't crash if we have 0 in the denominator. Oh, now we get a warning. Okay. Oh, we get a warning, but nothing crashes. Interesting. When I was doing this on Linux, the program crashed. Point being that if you divide by 0, bad things can happen. You can also, if we do floats, so if I do float d, and then do d equals a divided by 0, let's clear that, and let's, let me make sure I'm printing the right thing. Okay, that's right. Let's do this, let's do that. Yes, we're dividing by 0. Let's run it. And, okay, if you run this on a Linux system, you'll probably get the keyword inf coming up, like inf. That might be returned. Really, there's 3 things that can happen. So, dividing by 0 can result in, you can have infinity being returned, which is just a, it's like a constant, really. No, you can't use it as a constant, sorry. So you can have infinity, you can have nan, which is not a number, or you can also have the program may crash. Program may crash. They're kind of your 3 possibilities when you divide by 0. It's important to note that if you get infinity or not a number returned, these can't be used as constants. Cool. All right, so good job getting to the end of the video. If you have any questions, please post them below. In the next video, we're going to be going over inputting numbers from the user, so stay tuned for that one.